Down in southwest Florida, a completely solar-powered, climate-resilient town called Babcock Ranch is already fully operational. The community runs on a massive 870-acre solar farm. Every street is wired with buried fiber optics, and an autonomous transit network handles local transportation, while the fortified grid keeps the lights on through severe weather. Compare that to traditional coastal developments. When extreme storms hit, those neighborhoods frequently suffer catastrophic flooding, collapsed power lines, and widespread infrastructure failure. Babcock Ranch proves that fortified, sustainable engineering works. Now, the developers are using this physical environment as a living laboratory to test a much larger technological ambition. Globally, the way planners build modern, connected cities is highly inefficient. A developer typically has to hire dozens of different vendors to manage separate utilities. This diagram shows the result of that fragmented approach. You have distinct systems for water, power, and traffic, but they cannot communicate with each other or optimize resources across the entire city grid. To solve this, Executive Ron Wunderling delivered a radical proposal to the town's development company, Kitson and Partners. He argued they should stop acting like a traditional real estate firm. His pitch was specific. Kitson should use their ownership of Babcock Ranch to design, build, and test a unified smart community operating system. Building an enterprise-grade operating system for an entire city usually requires hundreds of engineers, millions of dollars, and years of coding. Wunderling established an aggressive internal mandate to bypass those hurdles. He requires the existing real estate staff to become authorized prompt engineers. Before anyone can access the company's development environments, they have to pass a mandatory course designed by Google to learn how to effectively instruct artificial intelligence. Armed with that training, a small, focused internal team can use models like Claude and Lovable to write code. Claude and Lovable are advanced artificial intelligence tools capable of writing and structuring complex software from conversational text commands. This allows the team to rapidly build complex software systems themselves. Artificial intelligence is not displacing the real estate team. It provides them the exact leverage they need to build a massive tech platform from the inside out. The team is currently building and testing a 5-module software suite called the Community Stack right inside Babcock Ranch. The Smart Community OS manages the physical grid, while the digital twin mirrors its energy flows. The third pillar, the Climate Platform, simulates storm surges and grid outages on this twin, identifying vulnerabilities before pouring concrete. The fourth pillar is the Builder Platform. This streamlines construction workflows, handles permitting, and tracks sustainability metrics for the major home builders working on site. Finally, the Resident app puts an AI concierge directly into citizens' hands, allowing them to track energy, schedule autonomous transit, and access community services. Because Babcock Ranch is a closed-loop system, Kitson and Partners can prove this software works on a physical, living population before attempting to scale it. The ultimate goal extends far beyond the borders of one town in Florida. Think back to the personal computer market in the 1980s. The hardware was fragmented and highly inefficient until a unified operating system came along and standardized the entire industry. This diagram maps out Kitson and Partners' intended software architecture. They want their operating system to be the foundational software that all future master-planned communities run on. Once the system is proven, they plan to license the community operating system to global municipalities, utility companies, and other large-scale developers. This strategy turns a regional land developer into an international infrastructure platform company. When artificial intelligence is grounded and rigorously tested inside a physical, living laboratory, it evolves from a simple generative tool into the essential infrastructure required to build resilient cities.